G'day, 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 you absolute bunch of bloody legends. A loser bum back on your screen with some high-speed delivery, low-quality, unscripted, single-take, unedited retro computing content. Today, we're not going retro gaming, we're going retro computing with hardware built in 2023. That sounds like a paradox. Let's dig it in. We love paradoxes over here. So what we're looking at today is the so-called Agon Light, in my case an Agon Light 2. The black belt of 8-bit, says there on the bottom, must be true. So it's a standalone microcomputer, an 8-bit microcomputer and microcontroller, but with modern design. Somebody at a place called the Byte Attic designed this from scratch, open sourced the hardware, and now there are multiple providers who will actually build one of these for you. The original, the Byte Attic, doesn't make them. They're not in the hardware manufacturing business. They're more in the hardware design business. I'm going to say it's a hobby. So yeah, design, you can download the circuit board, you could make it yourself, buy all the components, put them on yourself. In this case, you can actually get them, just get a ready-made one, and that's what happened. I'd been following this for a bit. I'll explain why of the Byte Attic. I actually followed the Byte Attic for something completely different, but when I saw this come across, I think it was Hackaday, and I was like, hey, I know that guy, followed it, and then I saw on Twitter that this company here, oh yeah, and it's certified open source hardware, this company here, Olimex.com, a famous hardware manufacturer out of Bulgaria, which is, as we all know, hyper famous for its computer hardware industry. Well, no, apparently, yeah, they make all kinds of little bits and pieces, and well, they do. So early in December, there we go. We've updated, and we're going to make it. So on 9th of December, they said, hey, available on pre-order, shipping end of January. Well, I pre-ordered 50 euros. Cheap, right? I mean, God, the work it would take to make all that stuff. 50 euros is, for me at least, absolute bargain. Went and pre-ordered it, and guess what? Even with some delay because of the mail, you see it in the unboxing video. So I did an unboxing live stream, but I had to abort because I ran into a hardware issue, which we'll touch upon in a moment. Fix the hardware issue, and this is a replay of the entire review, not just the unboxing. Anyways, they shipped it from Bulgaria, maybe on the 20th of January, so super early, like much earlier than they said, and it got here about the 25th, so I'm not complaining. They said what they were going to do, and they did it, and they did it a week early, and the widget came here. In fact, if I go over onto here, and let's go and have a look at the guy. That's what he looks like there on the screen here. Yep, you have. So it's a single circuit board. It's about, I want to say it's about, 1.5 size times the size of a Raspberry Pi, a little bit larger. You can't use the same cases. What's it got on there? You've got an SD card. We'll get onto that in a moment. That's a USB port, but it's not a real one. It's just for the keyboard. We will get that in a moment. Audio, VGA output, USB-C for power. I happen to have this USB-C thing left over from one of my Raspberry Pi 4s just plugged in. So, single board 8-bit computer. What does that mean? From the design, it's the same as computers where, like almost 40 years ago, the first ones I started with, which I owned, was a ZX81 and then later a Sharp MZ80, but also the Spectrum, the BBC, the Commodores, VIC, the Commodore 64. When you switched them on, they just switched on, and you were ready to go. So that was, I didn't time it, but it's about 4 seconds from power on to the point where you're ready to start interacting with the machine, right? None of this operating system and BIOS and all of that good stuff. It's like switch on, ready to go. And in this case, because of the way this is set up, by default, it'll drop you into BBC Basic. The BBC Micro, go look it up on the internet, was government sponsored and done by the BBC. Amazing machine. It was large for its time. I had the privilege of interacting with them in a computer science class in 1982, I want to say, in the UK. I still remember the physics teacher, because back then there were no IT teachers or computer science teachers. It was always the physics teachers or the math teacher. Here, have some hardware, teach the kids, and they would work it out. So this guy, little like ginger mustache, half balding, sleeveless V-necked sweater, but he just let us loose on these machines and taught us, and we started playing. So the BBC Basic, which was originally for the 6502 processor, same as in the Apple, and I believe in the Commodore 64. This BBC is a port onto the Z80 because the Agon Light is a Z80 machine. Now, it's not an old Z80, it's a new one, which has a much higher frequency, but completely compatible. So somebody apparently got the BBC Basic, fiddled a few things, combined it, and when you put it on the card, it'll drop you right in, and that's where you are, you know. Whoops, no, wrong keyboard. Wrong keyboard, you're right here, and if you do this, it's going to throw mistake instead of syntax error. You actually have to caps lock. In the olden days, everything was capital. Yeah, wrong quote. And typo, ta-da, we're in BASIC. 4 seconds and you can start interacting with a computer. How cool is that, right? And yeah, I'm running this, the guys who follow my stream, I've got an upscaler, which is capturing the screen input and all of that good stuff. Before we get stuck into with the BBC, a few, or the BASIC and all the other stuff you can do with it. Hardware-wise, as I said, the unboxing live stream was a hashtag fail because of this, right? So it says that it's a PS2 keyboard with a USB connector, and you know, why should I read up before buying something? No, I'll start a live stream and then wonder why it doesn't work. So this is a USB connector, but it's not presenting a USB protocol, right? When you connect a USB thing, there's a whole USB layer, your keyboard reports as a human interface device, and then something happens. This is just a PS2 connector, which is a much simpler protocol. It was designed only for keyboard and mice. It's still serial, but it's missing that USB layer, and they were just using a flat USB connector because it's more common than these old round ones. So what I did was dig through my pile, because yeah, retro, lots of pile of computer, found an old USB keyboard with one of these round connectors, cut off the cable, found a broken device which had this connector here, cut them off, wired them together with extremely high quality under here, as you can imagine, but it is soldered, and then it worked. Hang on, I can go back to thing. I can show you where that was. There's a guy, nope, not here. There's a guy on the internet who does this. I'll share the link in the description below, but you can Google it, who actually worked it out on how to get from the one connector to the other. I measured it through, but actually it's relatively straightforward because the how to say, it was the wires are almost the same color, so black to black, red to red, which makes sense because that's ground and +5 everywhere, and then white to white, which I think was the signal ground or the data minus, and then one of them was brown and one of them was green. Yeah, okay, so brown to green, plugged it in, and hey presto, it works. I have a keyboard that works. The other thing you need to do is to get yourself an SD card, and you know, look up online. It'll tell you what files to pull from GitHub and put on there. We'll look at those a little bit later. I made a mistake. I thought, oh well, this thing doesn't need a lot of memory, and I pulled an old 2 GB card which I had from somewhere, and this thing just wouldn't boot. It was saying, nope, don't know that. It says in the spec that you need a class 10. This is 16 gig, which I pulled again out of my Raspberry Pis. I assume it's a class 10. That old 2 GB definitely wasn't. Maybe a class 4. Doesn't like that. So again, read the manual, put the card in, and it comes up and it drops you straight into BASIC. So that's where that is. Where do we go from here? Let's have a look a little bit at what's in here. So actually no, before we're gonna do a thing, right? I'm gonna switch it off. I'm gonna pop the SD card and switch it on, just so you get a feel for what happens. 1, 2, 3, and we're up. And now you see we're not in the BBC Basics, so it's pulled from, it does have a ROM, a BIOS, which you can reflash, and we'll talk about what VPD and MOS imply, but it'll drop you in a shell. This is an operating system, a very primitive one, and you can type, if you know, oh, there's very few commands. Oh, cat, I'm trying to write, SD card failure. So even the BBC Basic, which we drop into, which we're going to do now, simply by popping the card back in, is already something that's running, right? So you could substitute that by something else. And here we are in the OS. The way to get back into the OS is to type *by. So when I'll slow down, loser bum, slow down. No, fuck you. So you can access the shell commands from BASIC, the operating system commands, by prefixing them with a star. And funnily enough, those are not case sensitive. So I can do *cat to cat, and now it's listing me the files. right? And it's actually already in a test subfolder. So I'm going to go star cd dot dot. That still works. Cat. Star cat, sorry, mistake. See, that's his words for syntax error. Mistake, cat, and there. Now we're in the root, and you see how it has an autoexec.txt file. That contains the instructions to load BBC Basic.bin, which you see there at the bottom, when it starts, just like the old autoexec bat in Word. So I could change the autoexec.text and have it boot into something else, which I don't know what that would be at the moment. We'll get into that in a moment. So, yep, you're naked in the operating system. You're there in the basic. One way to get into the operating system after you've been dropped to basic is to do star by, BYE, goodbye. Now I'm in the operating system and I don't need to prefix the start. Cat, it doesn't have many commands, so load. And here, when I'm in the operating system, I don't need quote. In fact, quotes won't work. So I just type the file name. It doesn't understand the difference between, a string or something else. It says, well, whatever comes now is going to be a string. He's done that. You load that. You run. And now we're back in the BBC Basic. Now that we're in the BBC Basic, we can try loading something. Mistake, because the BBC Basic wants everything to be in caps lock. Old C64 guys and in fact Sinclair guys will remember. Yeah, that's the way we would roll, right? Is that you had to be. You had to be uppercase for everything, which was switched on by default. So star cat. And we're going to go into resources. No, examples it was. No, it was tests. I'm sorry. So cd tests. Mistake, because the file name. File name first. It needs to be in quote, and it is case sensitive. So tests like that. So no. Is it star cd? Star cd tests. There we go. Now we're in cat. We're in star cat. Sorry. So yeah, use the operating system, and we're gonna start straight into the sprites one, the first one. So capital, because now I'm in basic. Load, and because I'm in basic, I do need the quotes, but the file name has to be lowercase. So sprites.bbc. Up. Load. We could list. Here is stuff. Run. Whoop. It's just switched video mode, which is why my upscaler needed the thing. And that's what he's doing. He's taking a sprite and just bouncing it across the screen. That's pretty smooth. I think it's 640 by 480 here, VGA resolution. Not bad for an 8-bit Z80 computer. Escape. It's not Control C, but escape is your escape here. You'll notice you can't see the full screen because my upscaler doesn't really like this mode. Maybe it's more like 320. It's like so. Then we do old school mode. Nope, capitals. Mode 0, and we're back in the high resolution mode. This one's 640, which works better with my upscaler. Let's list that just a little bit. No editor, no backspace, so nothing. So it's a little bit annoying. What we're going to do is take line 640, data, and then we're going to do 255, and then 64, 64, 64, 64, 64. 255, 255, 255. Now I have to count. There's actually 16 of these, right? This is what he's doing there, is building up the sprite. See how the line 550 has nothing but white pixels, right? This is a 8-bit kind of pixel thing. And there's 16 lines, so he's just building up a 16 by 16 sprite. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Need 7 more. 9, 10, 11, 12. Bugger, made a mistake because I didn't do comma. And there's no way to backspace. There's no way to backspace. There's no way to edit. 5.61. 2. No, that's like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've now changed one line here out of the sprite definition, somewhere in the middle actually. So let's list that again. Yeah, and if we run, And with he's doing that thing again, you can hopefully see on the screen how I've got a sort of grayish line in the middle of my sprite. So I can put some sprites in there. Welcome to Sprites Graphics in BASIC on 8-bit in the old school way, but on 2023 hardware, which is so fucking cool. Sorry about the swearing, but I am really excited. So back to mode 0. Show you 1-2 more things in BASIC, but you get the gist. I mean, BASIC is what it is, and it's literally what it is. It's as good as it gets, and it's about as it gets, right? You're limited, but you can do anything. One thing I still need to figure out, the BBC Basic .bbc, or sorry, the .bbc files are not plain text files. There's some gunk at the front, so at the moment, I cannot edit these text files on an external machine, which would be a hell of a lot faster. Gonna be investigating that at some point, but hey, we'll get there. We'll get there in the end. So I'm gonna do the old new, if anybody remembers that. New clears the memory just in case. Then we're going to cat, and we're going to get sprites 5s because it was pretty impressive actually. Load with a thing, but lowercase sprites 5.bbc, and I guess these example sprites 1, 2, 3, 4, 5 just kept layering more and more stuff. This is the conclusion of somebody saying, yeah, I'm going to smear lots of stuff on the screen. So let's run that. Same thing. He's still flipping on the mode. How cool is that, right? A bunch of, by the way, that blinking is an artifact of my upscaler on my other monitor, which I have here. It's fine. And yeah, so he's got a scrolling star field in the background, and he's got a fair amount, you know, a couple of dozen of blinkies, twinkies. I can't remember which one in the red one is called, Inky, just bouncing around the screen, and they've got little yellow eyes. So that's kind of cool. So, what else can we do? We'll start with hardware. Hang on, mode 0. We'll start with hardware stuff. We'll do new. So the next thing is here that it's got directly GPIO pins built in. So it's like, that's why they call it a microcontroller. You can use the BASIC to control the GPIO pins to get inputs and output, and theoretically control your smart home with this kind of stuff. So here's a little widget I've prepared earlier. Let me get that cable out the way. So it's very simple. I've got this cable here goes to ground, which is on pin number 3. And you can see from the little lettering there that these are actually ripped out of an old PC thing. So that, oops, that cable goes over here. Yeah, bugger. I have to put that one back in the hole. There we go. So we're going ground to this side of this LED. Right, then that's contacting the LED. Oh, sorry, and there's a resistor. It should be 4K. In my case, it's 3, but that's fine. That's then connected to the LED, would be the cathode, I guess, the minus. The plus is going over here and being connected to pin number 17 or 19. If you want to see where that is on the Olimex blog WordPress site, it'll describe exactly what I'm doing here. So now that's plugged in, the LED is off. This might be hard to see on this camera. We'll see what we can do. Can we actually make that bigger just for now? Yeah, make that a little bit bigger. So it's off, and now I'm going into again the basic, because I already did this. Load LED b.bbc, and we're in, and we're going to list that very simply. So, oops, I wonder if that works. Oh, interesting which are going to work, because one thing which I haven't done here yet is set this thing to be an output pin. We'll see what happens. So what he's trying to do, the put 158 just says, hey, put GPIO pin 0 to up, because it's 1. Then I'm using the in key. In key is keyboard capture, and it's waiting 500 milliseconds. And then, so it's just a pause because BBC Basic doesn't have a native sleep. And then it puts 158 to 0, so switches the LED off, and then go to 10. Any good basic program finishes with go to 10. So we'll run this. And it's not working, and so we escape, and now we go to my other display, because if I go, whoops, daisy, no, wrong keyboard. See, now I get confused. Open hardware. There's the whole instructions. This is the, nope, this wasn't it. Hang on. There we go. Blinking lights. And what I got to do first is put 159 to 254. Don't ask me exactly how that works. I will read it, but so put and get in my old word would be poke and peek. Now, you're writing to memory addresses actually in decimal rather than binary. But okay, and put 159.254 is going to tell this thing to make that pin an output pin. So put 159,254. Sorry, lads, gonna switch back over so you can see that as well. And here we are. Right, so done that, run. Yay, you can just very faintly see it blinking at what technically would be about 2 hertz. So hardware control straight out of BASIC. You wouldn't do this stuff with your old C64 because that stuff was very expensive. Your father paid for it and it's for educational use. It's not supposed to be playing games. So they started putting wires in it, getting it wrong and frying something which is worth more than a year's of pocket money, right? You wouldn't do that, but here, yeah, you can, and he's still blinking. So hardware works, check, right? To make that, that's about all we're gonna do on the hardware. So where do we go from here? Let's do a very quick conceptual run first, because I think it's important. I thought it's kind of funky as you dig into this. It's quite kind of interesting. So let me switch back to this guy, back to the browser, and if we go back to the Agon Light, the actual page, let's look at the architecture of this thing. The guy's got a nice diagram. I hope it's here. Here's some benchmarks. Estimated to be way better, about 20 times better than anything else. There you go. Here, Sinclair ZX Spectrum for a Battle Royale basic performance spec, about 4 minutes. Argon Light, 7 seconds. We're here. Ah, yeah, here's the architecture. So an interesting thing is this takes us back to the boot. In fact, not only do I power cycle, I've got a reset button on here. I don't even have to power cycle. So I'm going to power cycle this, and later on we'll have a look at that. But you see how he's loading the VPD and the MOS. The VPD is the right-hand side, which is kind of the video processing thing, right? And the way that works, which I find amazing, is like the job of doing the graphics card, right? You've got a graphics card on board here which does VGA, also controls the audio. There's a little speaker, you can make this thing go beep. Yeah, there's a little speaker, but the VDA, the audio, and some other stuff are powered. I hope you can see it, but it's an ESP32, right? ESP32 is the system on a chip things which you use for microcontrollers. I have some to like control little robot-y things. So rather than get into the whole thing about, oh, what graphics chip am I going to use? Nope. This little ESP32, I've seen this done before in one of my other things, right? This ZX81 here has an ESP32, which allows it to even do Wi-Fi, and it has the option of doing VGA, because all this little processor is doing is driving some pins and then emulating a VGA output. It's so fast that, yeah, I'm sure I'll throw frequency at those pins and make your monitor think I'm a graphics card. And then, so that's where, so if you want to change your visual processing firmware, basically you have to go in via USB connector and flash this ESP32, which is like kind of Arduino stuff. I think, yeah, you use the Arduino toolkit to flash this thing, and hey, you've just upgraded your VGA. In fact, there's one example where you got to do that to run a CP&M operating system, which somebody's built. So, and what I find funny is that the communication between the CPU, which is over here, which is talking to its graphics card, rather than come up with an ISA bus or a PCI or PCI Express or whatever the hell kind of blackplane, nope, it's 384 kilobit per second serial link. So, right, the CPU, all it's doing is driving information over to the internal serial interface, which is on the board here somewhere, throwing a stream of bits at the ESP32, which is using his Arduino-like program brain to take that stream and said, okay, I'm going to build a screen and throw a VGA signal, which means once you get, and program, that's going to be hard. It's up, down at the hardware, but you can do things with the audio jack. You can do USB, and you can do funky stuff on the VGA. As I said, on the CP&M thing, you had to do that because that's a better VPD, which which apparently emulates an ANSI terminal. So I'm interested, but the flashing. So yeah, it's loading the VPD. That's why I reset the computer. Hang on, I'll demonstrate. Look, reset button. When was the last time you had a computer with a reset button? Reset. 2, 3, 4, and we're on, right? So first thing he does is like the VPD loads. I don't know if it loads first, but it's the first thing that's talking to the video card, right? It's saying, hey, your graphics card came online and is pushing that signal to the VGA. And then the Argon MOS, the operating system, hey, I'm here, goes to the auto exec, runs the BBC micro and drops us into basic. Oof, that was exciting, wasn't it? It's like that. And, actually, I want to show you one more thing in the software here. Let me go to, okay, woo, this is always the trippy one because I'm actually screen sharing. So let's hope that this works. Actual screen capture. All right, I have here ZDS. I don't even know what that stands for. Again, if you look on the Argon page, you find all of this about it's the ZDS, it doesn't even say what it is, but I think it's the Zilog Development System 2. Zilog being the Z in Z80 is Zilog. They're old, right? They've been around forever. I guess the brand's been bought a few times. So on here, I can do the following. So this is a full build environment, free, and I'm going to open up a project. Again, instructions are on the web. You just got to download all the files, download this thing, download one extra file, which is like the API. It's like an include file, and you go here, and here you have a bunch of assembler file, right? This entire thing is written in assembly and GPIO and init and whatever. So I don't know if I'm going to get back into Z80 assembler. I was never that good, but yeah, LD means load this thing into that thing or the other way, and then copy and then jump and then do stuff. Yep, so you can, yep, so there's a bunch of assembler, and all of this assembler here is basically the BBC Basic. Cool, so who cares, right? Now I'm going to go to build and say rebuild all. Takes a few seconds, chunka, 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 chunka. He has built it, relisted, and whatever. If I now go to the folder debug, which is over here. So this is, oh yeah, this tells you how old this ZDS is. When it installed, ruthless, went to C and made its own Zilog folder because fuck programs, my programs or my documents, they're going straight to the hardware. And then under projects, which is where I am, you go to debug and to debug. Oh, am I in the wrong project? Hang on, projects. Why didn't that work? Oh, that's sad. I had this main.obj. Why is he not doing this? One error, or did he build it somewhere else? Where did he drop this stuff? Oh, did he build it in the? He could have built it because I've got the source in my downloads folder. Maybe he dropped it in there. Let me see if I can find that. Yeah, Agon, here's the BBC Basic with the files in it. Oh, see, that debug folder here is not there when you actually download the stuff. So he created the debug folder, and he's now got a file in there. You can see from the timestamp, yep, that's today. I am bbcbasic.hex, and I'm just going to convert or rename that into BBC4, just to, whoops, that would not be good because dollar. So BBC4, I've got a hex file, and now because of reasons which I need to work out, you need to convert this hex file into a bin file, and I found a thing on the internet where there's a hex to bin command line utility, so I dropped the file in there so I don't have to muck about with folders. Here I am on a shell. All right, so now I'm going to do hex to bin on that BBC4 file. He's done it, listed again. I now have a bbc.bin file, right? Now I will, well, what I'm going to do is, you can't see this, but I'm switching off the machine over here. I'm taking out the SD card. I'm putting the SD card in an SD card reader, plugging the SD card in my laptop here. You might have heard it go blinky blink there. Come on, show up. He's not super happy at the moment. Maybe I need a bit of... There you go. So here you can see that's the listing which we get when we do cat on the device. I've got my BBC Basic, and I'm going to paste the, nope, not the hex file, sorry. Yep, delete that. It's the other one. It's the bin file I want. I'm going to copy. So what I just did was compiled the entire programming language from source, dropped it in, renamed it. Now we'll take that guy out again, and now we can move back over to the other screen. And here we are. Hello. No, that one. Right. So take the SD card, plug the SD card in, power up of the device. 3, 4. There he is. There he is. Okay, of course, that's just the normal BBC Basic. But if I now go and do the old buy, so get out, and I do a cat, you can see that I've now got a bbc4.bin in there, which I just compiled and just created. Note how it has exactly the same number of bytes. Load bbc4.bin. Done. Run. And I'm in the BBC Basic, but it's the one I compiled. If I wanted to go and start mucking about in the assembler, I can make my own. How cool is that, right? So we got hardware, we got operating system, we got funky VPD serial port stuff, and we can assemble our programming language from, and other things from source. Where do we go from here? That's a very interesting thing, right? I did see that Zilog ZDS development interface is able to process C files, so I'm assuming it'll compile down from C into a hex file, which I then take through the bin, but I'm sure that needs a bunch of header files in includes, which I haven't found yet. What else can you do? Well, you can program in BASIC, but you have to do all the typing in this rather clunky interface until you find a way to edit the BBC BASIC files directly with 17 petabytes or however big the internet is, these exabytes actually these days. I'm sure somebody has solved that equation before. You can do hardware stuff. You can rewrite your own video RAM. Somebody has rewritten the MOS to make actually a CPNM, which was a very early operating system. You can do a bunch of things. So yeah, that's kind of cool. That's kind of cool. What am I going to say? Yeah, when I made this video, it was from for a friend, Lispmeister on Twitter. Follow him for book recommendation, cryptocurrency at your own risk. But yeah, the Lispmeister, my generation, was like, hey, is this thing worth it? Well, here's the video, and we're now getting to the conclusion thereof. It's fun, right? I mean, you switch it on, stuff happens, you can make stuff go blinky lights, you can load stuff. There's very little software on there, and, you know, if you want good stuff, you're probably going to have to write it yourself, and you're going to have to get familiar with an architecture. And in a way, I think that's the experience with the advantage of the internet. Allow me to explain. It's like, in fact, it's like back when we first had these computers, there was no internet. There was nothing in the library. You got a computer. If it was first-hand, there was the manufacturer's manual, which was sometimes good and sometimes maybe somebody bought you one book with some programming examples. But all the good stuff, the pokes, the peaks, the hardware, the how do I make it do stuff, games, right? You had to find somewhere, and it was always by human contact. If you lived in a village with nobody, right, you couldn't copy the games, you couldn't get any information. There was nothing in the libraries, and there was no internet. And that's where this thing, in a way, is, in the sense, well, there's almost no operating system. I'm pretty sure nobody's selling software for this. I had the idea, could we get Zork ported onto this, and I saw, well, somebody has made a Z machine interpreter for CPNM. Unfortunately, the ZPNM port which was made is for the Agon Light and not the Agon Light 2, which is the one by Olimex, and there seems to be some incompatibility. So I can wait for somebody to take the CPNM and make it compatible with a Light 2, or I can try, because the source is on the internet, plonk it in the compiler and see what happens, and then see, will that actually load a Zork game? So you're in this depth of hardware down very close to the metal or in the operating system, but you can still see the metal from where you are. Assembler, C, stuff not working, and all of that. But that was the cool thing about 8-bit computers back there. You could make them do anything which was limited by your competence, your imagination, and your availability of resources. And now have unlimited resources. There's a community around this, but it's a Facebook group, and I'm not going back to Facebook if I can avoid it. But hi guys, if you see this video, I may join at some point. I have no clue what I'm going to do with it next. I got one video out of it, and already had to take some hardware apart and wire some cables together. So for 50 euros, I got me money's worth. And yeah, I suspect I will be following this. Maybe, yeah, don't expect me to contribute that much code. I'm not that good at stuff. But, at least get to the point where I can write an assembler program which just prints hello world and compiles down to one of those binaries. Yeah, sure, I'll try that, and if I can get it to do graphics, maybe do a little bouncing ball bypassing the basic altogether, because why the hell not? Maybe there are some cool basic games which are compatible with this version of BBC. Don't know. Okay, almost it. Thank you for your patience. As always, this has gone on probably a little bit longer than I would have wanted. Last little tour on to the old browser there. Let me see. Can you still see that? Are we in the browser? No, we're not. There you go. Hey, why are you not going to the browser? Go to the browser, you bugger. You're supposed to capture that thing. There we go. Yeah, because if the window's minimized, you can't see it here. Anyway, there's a bunch of videos on the Byte Attic homepage, and you'll see this guy here with this face. It's Armando. It's something Kastrup is his last name. Never met the man, but I have to go. This is how. There he is. That's a beautiful picture. That's his GitHub repository. You can see he's doing other computers in 8 bits, because he's got one, the Cerberus, which has like 3 processors on it, because of course. And the reason like I said, I knew him, and it was like familiar when this popped up on Hackaday, was what he did. He did a series of videos on the Sharp MZ80K museum quality restoration. Apparently, one of his jobs is getting paid to restore really old computers, and this one was a museum grade restoration, because it's actually going to be a consumer in a computer museum somewhere in Netherlands, where people with their sticky fingers are going to be punching buttons. So it had to be restored from scratch, and he had like a 10-part series on how to do that. Now, the first computer I ever owned was this ZX81, a Z80, but it had like 1 kilobyte of main memory. Maybe I'll do videos about that some point as well. This one sort of works. My hardware, my memory upgrade has gone a bit, but anyway. And then the second computer I ever owned was a Sharp MZ80K, made in 78. I got it maybe in 81, 82. And it was alien. Look at it. Like, the keyboard the keys aren't even offset. You can remove the keycaps. It's Japanese. You had to load the BASIC from tape. None of this SD card, which took a while. And it had a built-in tape drive. That was the storage. It had a built-in monitor. Had this clunky keyboard. And yeah, because it's very arcane. Not many people know it. I'm always grateful for resources, and I've got one. It worked when I bought it from eBay about 7 years ago. Last time I tried to switch it on, it's dead, probably leaking capacitors. So having somebody like the Byte Attic going through a step-by-step restoration is awesome. When I have some time, I will myself go see if I can revive that machine and see if I can show you some information about that. All right, we've reached the end of that. I hope somebody enjoys it. If not, I certainly did. Thanks very much for watching. You're the internet. I'm Loserbum. You're all a bunch of bloody legends. And I am out of here.